Hey, good evening, everybody. Welcome to Meteorology Lab once again. Clear skies. We don't have a whole lot of weather going on, so we're kind of off to a very slow start to May here. Taking a look at the surface map, let's go ahead and head over to that. This is a plot with digital atmosphere, and we can see that there's very little in the way of surface systems. There's a weak one up in the eastern Midwest region, and then we have this departing weak polar system heading out off the coast of the Carolinas there. So what is the prevailing pattern? Well, we can look at the highs. So we see a little bit of high pressure up to the north over the Great Lakes. That's representing a cool air mass pushing southward across that region. We can see the eroded high pressure region. This is kind of what we were referring to as a bit of the Bermuda High. Just very little of that left. And that's where it's located. The stronger cold air is offshore. And then that brings us to the western U.S. You can see a little bit of troughing in eastern California and Nevada there. So this here would probably represent maybe some thermal troughing. And then everything around that kind of indeterminate. The flow just kind of being dominated by the strong heating underneath that ridge there. So we can put that together with the surface map. Here's the isobars and thickness. Definitely got a very strong system up there in the Canadian Arctic. So the front is just north of the Prairie provinces, right up there. And then, let me redraw that. There we go. So that's the next cold front coming out of Canada. And then we've got this warm front there in eastern Manitoba. But as mentioned, it is pretty quiet in the U.S. The main feature, this high pressure in the Great Lakes region and the low in the Great Basin area. So we're under a little bit of weak southerly flow in Texas, but that's not hooked up with the better Gulf moisture down in this area. This is another way of looking at the systems. This is the SPC mesoscale analysis. Not a whole lot to see today. In fact, we can take a look at the instability surface-based CAPE, showing that we have some slightly elevated values in Arkansas, Missouri, Oklahoma, and Kansas there, but it's only about 1,000 joules per kilogram there. Very weak instability in Texas underneath high pressure in this region. And it does look a little bit unsettled in the Montana-Idaho region. So maybe a little bit of a cold core low in that region. So we'll kind of take a look at that. This is probably, there's probably a little bit of upper air troughing in that region. Here's the 250 millibar analysis. So a little bit of that instability in that region, probably associated with that wave right there. And then you can see the ridging across the Rockies right there. Starting to get some strong flow coming onshore in Northern California. And then taking a look at 700 millibars, you can see that we're not exactly capped, we're just kind of lacking low-level moisture. 700 millibar temperatures ranging from about 4 to 6 across Texas, maybe 4 to 7. So if we had a little bit more moisture, we would almost certainly be seeing thunderstorms today. And then we can also see the anticyclonic flow in the Four Corners area, 700 millibar high in that region. And then going down to 850 millibars, you can see we're starting to pick up a little southwesterly flow there in Texas. But off the coast around Corpus Christi, Houston, and Lake Charles, the flow is still out of the north. So there's not going to be very much going on for the next day or two at least. So that brings us to the satellite imagery. There's a look at the last couple of hours of daylight there on the Great Plains. A lot of high cloud there, lots of cirrus coming over the north side of that ridge. And we can see the flow becoming a little bit stronger out west. Starting to see some jet stream cirrus in that area. And up to the north, we can see those anvils up there in Idaho and Montana. It's kind of ironic, early May, that you'd have to go all the way up to Montana to see any good storms there. In fact, that looks like a good anvil right there, just northwest of Boise. Let me see if I can zoom in on that. I'm just kind of curious about that. Well, okay, maximized. Let me back off on that. Hang on a second. There we go. So this is Oregon right here. And then up here we have Washington, and then this is Idaho. And so that storm we're referring to is right there, crossing over into Idaho, and it's probably not going to be very severe. In fact, you can see a very small overshoot there, but it is isolated. Neat little isolated storm, and actually, yeah, in Oregon, looks like a couple more anvils out here in the Columbia River Valley. Okay, let me see how things are going in chat here. I'm surprised we got this turnout tonight, since there's not much going on. But we will be going over the journals. Haven't forgotten that. Ron Chalfant reporting 70 to 90% cloud cover above 20,000 in Southern California. Electric Dog 54 in Northeast Illinois. Carl Berghoff and Funwatech and Willie Greenway are joining us here. David Lumbert, Central Arkansas, 67 with thunderstorms. Winds gusting up to 60 there. Adam Davis, nothing exciting to report. Andrew Hotchkiss likes the time-lapse. Appreciate that. David Holcomb says it's starting to feel like summer in South Texas. Pretty boring where Justin Pulliam is. Christian Flock. Yukon, Oklahoma, beautiful evening there. Mix up the satellite a little bit so we're not stuck on the same loop there. Ryan Toomey's there in Florida, also joining us. Adam Davis asking if the Canadian highs can plunge south throughout the year. Yeah, definitely. They can pretty much go all summer. The thing is that they lose their definition very quickly. It's very common in June and July for those cold outbreaks to push sometimes all the way down to Mississippi and Alabama, Arkansas, and they stall out there as a stationary front, and we get several days of thunderstorm activity. So that does happen a lot during the summer, but I don't think it goes any further south than the Red River. This is probably about the limit here of those outbreaks in the middle of summer. And then in August we may see them starting to come into Texas and Louisiana there. But if you want a good example of one outbreak, check the NOAA daily weather maps and go to around the first week of July 1997. There was a strong one that came all the way down to Texas, and they were in the 50s in Oklahoma City around July 3rd or 4th. That was a cold one. Dean Benedict is here, and Shirley Keast, 52 in Michigan. Still not breaking the winter chill there. Very slow start. Carl Berghoff calling that. Michael Davidson is near Moore. Rainy day in South Florida, Ryan Toomey's. Kathy Vanas, 81 in Overland Park. No wind. Front blasting through Florida there. And that's from Ryan. Mike Estwick and Chris Tyne joining us. Mike saying 79 in Denver. And Michelle Curlin watching some tornado footage there. Okay. let's go ahead and head into the rest of it. And yeah, I do have that journal stuff ready to go. We looked at this a little bit last night, but this is kind of a very detailed statistical paper, and I didn't want to start putting some inaccurate stuff on the broadcast. So let's go through this. Again, this is a climatology of significant tornado events from 2012 Weather and Forecasting. So this looked at tornado events 2000-2008, and it also looked at some severe weather. We're talking 2 inches of hail and 65-knot winds. So what do we find out? Starts out with the basic assumptions there. Typically weak forcing associated with discrete cells, and strong forcing gives us the QLCSs, which are basically squall lines and MCSs. And this radar presentation shows you archetypes of those. So here's the discrete cell, and you can see there over Wichita and even Oklahoma City, a couple of isolated cells. And then the QLCS is this right here, classic MCS appearance. And then we have the cluster where it doesn't really fall into either category. So we can look at the charts here to get a visualization of that data. So starting out here, significant tornadoes. This shows you the type of storm associated with those tornadoes. We're talking at EF2 and above. And obviously discrete cells, supercells sitting out there by themselves, those are responsible for most of the significant tornadoes. However, a lot of them associated with linear storms. And then over here on the scale, this is interesting. This classifies them according to F2, F3, and F4, F5 tornadoes. And we can see that discrete cells become rapidly associated with those stronger, violent tornadoes. And only I guess that would be a total of 5 instances of squall lines and clusters being associated with those strong tornadoes there. This is the distribution map of tornado events, so obviously the majority of them in the southern plains, and then the runner-up, the Midwest area. So I'm not going to show you all these graphs, I'm just going to kind of hit the main points here. This right here shows us that during the cool season, linear storms produce most of the significant tornadoes. And then when we get into spring, discrete modes rapidly take over there. Then we've got some other visualizations here. The warm season, you can see the discrete cells are most popular, most common around 22 to 0Z. So that's going to be early evening. However, by cool season, you can see the linear storms show a maximum around midnight. So when we get after dark there, even several hours after dark, that can be kind of significant for tornado outbreaks there, especially in the southeastern U.S. And yeah, one other thing here. Yeah, right here. See, right there, this is the quasi-linear convective systems for the cool season, showing an actual minimum in the afternoon, 19 to 21 Z. That's going to be about 1 to 3 p.m. It's showing that very few strong tornadoes associated with linear storms, and even not too many with discrete cells. So definitely, as we get later in the evening, that becomes more common there, and that's probably indicating that those systems are more synoptically driven. And let me just scroll down here. What else did I find? Let's see. Yeah, this is the upper air wind direction with tornado events. You can see that in most areas we're looking at southwest to west-southwest flow. But in the case of the southeast U.S. in the fall, they're a little bit more southerly. And that could be due to possibly tropical cyclone tornadoes. Maybe it's picking up a few of those. However, southern plains during the spring, south-southwest winds predominant at 850 there. So that shows that the springtime, we're looking at probably a very backed flow through a rather deep layer there. And let me just kind of scroll down here. And I will show you something that is very interesting. This is the wind speed for all the different types of severe weather, hail, wind, and tornadoes by region. And one thing that really stands out here is the tornado events. They're all associated with strong 500 millibar winds. Not so much in the northern plains, but you can see that this really kind of discriminates very strongly with the hail and wind events right here. So wind speed is probably a very good predictor there at 500 and 850. In fact, if you compare that with shear, here's the shear parameters. You can see that using bulk shear, bulk wind difference, there's not as much discrimination there. So it's kind of weird, there's the shear. You've got probably moderate correlation, but if you take that wind speed, that really stands out, the difference between tornado events and hail and wind there. So that was kind of surprising there. And then just going over the rest here, let me see, what else do I want to cover? Let me scroll down to the bottom. So we could probably be going at this for 20 minutes, but I'm going to keep this focused on the basics. Let me find, hang on a second. Yeah, there's the CAPE parameters there. And you can see that with tornadoes, CAPE is not especially good as a predictor. So you can see that wind and hail events, they're pretty much in the same ballpark there with tornadoes. So going by CAPE alone, that's not itself a good predictor. However, one thing I did find, tornadoes, looking at capping, this is convective inhibition, they're less tolerant to strong capping. So this right here, this would be the strong capping range, and this would be weak capping. So typically with strong capping, we're looking at hail and wind events, but the tornadoes, they really like to be right there in that weak to moderate classification there. And let's see, what else? I think that's probably the key details. Anyway, that's 2012, volume 27 of Weather and Forecasting there, Grams and Thompson, 2012. So that's a tornado climatology, and hopefully tomorrow we're going to look at another paper. And hopefully, what I want to do is, like, day by day, we'll kind of build up on this, and after we've gone through maybe 2 or 3 weeks of this, we'll know a whole bunch of new fundamentals, new findings about severe weather forecasting. So tune in tomorrow and throughout the week, and we'll go over more of this. So let's go ahead and get into the forecast. Take a look at the upper air patterns. There's the 500 millibar chart, and we can see that strong ridging there in the Rockies. So downstream from that, that tends to be a favored area for subsident motion. So over the rest of the weekend, we're just, well, it's actually Sunday. Yeah, over tonight and tomorrow, we're going to be seeing that ridging building in. One trough passing through the northern plains there. In fact, let me back that up and look at this evening. Yeah, that's what's giving those thunderstorms out there. See, there's that shortwave right there. And those thunderstorms we were looking at on satellite were in this region right there. So that corresponds pretty well to that area of ascent. Let me see if I can bring up a couple soundings. I'm going to go for that one that's in Idaho. And this should be valid for right around now. Looks like some very good instability in that region. However, moisture has been on the low side. But some very good lapse rates through the lower and middle troposphere. Bulk wind difference, not very strong at all. Pretty much all the 0 through 6 kilometer winds falling in this box right there, but looks like a little bit of separation there between... No, actually not. Yeah, the wind profile is very weak and not entirely favorable there for tornadoes. So the algorithm here going for marginal tornadoes, but if you look at the weightings, the weighting factors, it's going mostly by the Cape and the low LCLs. Everything else not all that great. So let's see what's going to happen over the next couple days, going to tomorrow afternoon. That trough will be moving out into eastern Montana and Wyoming. So maybe a chance for some thunderstorms in that area right there. It's a good way to get away from the chasers. Head up to southeastern Montana. And then that wave will be moving through the Dakotas Monday night. And then by the time heating starts springing up for Tuesday, that area of lift will be moving into the lower plains around Minnesota and the Dakotas. And it looks like some of that troughing will be even moving down into Texas and Oklahoma there. So we'll have to look at the surface pattern to see if we've got enough moisture. More ridging coming in for midweek. So we'll be shut down for a few days. And then we'll have to pick up the GFS, and let's see what that looks like. Here you can really see the long wave ridging. Pretty much all of this is long wave ridging right there. So that's one of the reasons it's so quiet there. This next low pressure system offshore heads mostly up into British Columbia. However, the flow does start accelerating out there in the eastern Pacific, so that will bring some stronger flow into Nevada and California. And then the next synoptic scale system is probably going to be this next big wave coming up for next weekend. So probably by Saturday, maybe in the high plains, maybe eastern Colorado, a chance for thunderstorms in that region. And then Sunday, also looks like maybe some central plains action, maybe down to the panhandles. So we're going to be under the influence of this cyclonic flow during the weekend. That should bring the chances of storms up, give us something to look at there. And the next wave heads up into the Great Lakes for Monday. A little bit of troughing hanging back in the central plains. And then we'll see that ridge building in once again. One little wave departing across Texas Tuesday and Wednesday. And then we're looking at the following weekend for some more severe weather, it looks like. But you can see that ridging. Looks like that's going to be kind of a persistent theme over the next 2 weeks or so. So let's look at the moisture there. You can see the moisture is kind of depressed, lots of 50s and low 60s dew points in Texas and Oklahoma there. And a lot of this is coming from evapotranspiration. So it looks like some of that moisture will be heading up into western Nebraska, western Kansas, and the western Dakotas. So maybe a chance of thunderstorms up there tomorrow. And then going into Tuesday, things are going to be looking like this right here. Moisture builds up a little bit there in Kansas. Let's see what kind of depth we're looking at. Again, this is Tuesday. Moisture depth is a problem. Looks like only about 75 to 100 millibars of depth and some capping. 700 millibar temperatures up to 8 Celsius, and that with moisture problems probably spells very little severe potential. And then we go up into Wednesday. Looks like another front coming southward into Kansas. That forcing there could increase the chance for activity, plus the moisture axis crossing that boundary right there. Could be a little bit wet there in Kansas on Wednesday. We'll have to see about that. Let me check the soundings. Capping does look a little bit weaker, but moisture is still kind of iffy there. Not much improvement in the depth of that moisture. Then we get into Thursday. Looks like a southerly flow picks up once again, and we bring up a little bit more moisture northward. Here's the next front. That's probably not going to be moving south, because you can see the mean flow across that boundary is south to north. And I don't see too much organization on that dry line out west. I really want to see those that moisture gradient coming together in this area, and we just don't have that. So I think we're seeing very little in the way of lee side troughing there in Colorado, probably due to that ridge across that area. We do get this one low here around late Thursday, maybe a weak system there in Kansas, so maybe some potential coming up here for Friday. See, now our lee side trough is really developing, and we're now seeing that moisture really starting to organize there. So maybe a chance of thunderstorms there along Interstate 70 on Friday. Then for Saturday, looks like maybe a Northern Plains event. Now you can see the dry line is organized. Let's see what kind of capping we're going to be looking at. Let me bring up a forecast sounding for Wichita. Pretty strong cap there. And yeah, look at that, 700 millibars, 12 Celsius. So that may limit the southward extent of storms along that dry line. Convective temperatures. Those are going to be about 98 to 99 Fahrenheit. So I'm not too sure if we're going to see anything down that dry line on Friday or Saturday. We'll just have to see. The main front comes southward on Saturday and Sunday, so there could be some forced convection along that. Also along the warm front in Illinois, possibly some storms there. And then this high will be building into the plains over the weekend. And then the next chance of organized severe weather. Possibly some high base storms during the week around the 17th and 18th. And I think we're going to have to wait till about the 21st to 22nd for this moisture to start recovering. So that's about all I got for tonight. We're not going to be totally devoid of severe weather chances, but it will be kind of a touch and go here, I think. Let me take one last look at chat here. Double-clicking the SPC hourly mesoscale map brings up a tornado climatology. Yeah, very good. I wasn't aware of that. Thanks, Andrew Hotchkiss. Area between the red line and dotted line on a SCUT chart. Yeah, that roughly approximates Cape there. A little discussion about the books. And I think I'm done. So, pretty slow Sunday. Maybe we'll have some stuff to look at tomorrow. We'll see. So we'll keep an eye on the Dakotas there tomorrow. Other than that, I guess it'll just be kind of quiet for here for a day or two. Anyway, we will talk to you tomorrow, and have a good rest of your evening. Thanks.